Nerd time, wait! When you heat a bottle of water, something weird happens. First of all, the temperature rises. Who would have guessed? But then, it suddenly stops, even though heat is still being added. That energy didn't disappear, it's just being stored. Let's find out why. So far, we've seen how water's structure and formation makes ice float, how cohesion creates surface tension, and how hydrogen bonds shape water's behavior. Today, we're gonna look at what happens when energy enters this mix, and why water is so good at holding on to heat. First of all, we need to know temperature versus heat. Temperature measures the average motion of molecules, while heat is the actual energy being transferred from one place to another. They're related but not the same. For instance, you can add heat to a substance without increasing its temperature. I know, doesn't make sense, but water does this better than almost any other common substance. Water has a high specific heat capacity. It can absorb 4,184 joules of heat, or 1 kilocalorie, for the temperature to rise 1 degree Celsius for 1 kilogram of water. Basically, that just means it takes a lot of energy to raise water's temperature, and it releases a lot of energy when it cools. Why? Much of the incoming energy goes into stretching and bending hydrogen bonds instead of speeding up the molecules directly. With that idea, water doesn't necessarily heat up quickly, but it also doesn't cool down quickly. And during phase changes, energy doesn't change temperature, it changes structure. When ice melts, energy is absorbed to break hydrogen bonds. The temperature stays the same while the structure changes from solid to liquid. When water freezes, that energy is released back into the environment. This hidden energy is called latent heat. Evaporation requires even more energy. Water molecules have to completely escape the hydrogen bond network, and when water vapor condenses, that stored energy is finally released. This is why condensation can warm up the surrounding air. Because water absorbs and releases so much energy, it acts as Earth's thermal buffer. Oceans store heat during warm periods and release it slowly during cooler times. Phase changes in the water cycle move massive amounts of energy around the planet, powering weather, storms, and wind patterns. Without water's ability to store heat, Earth's temperature would swing far more dramatically. Once again, water's strange behavior comes right back down to hydrogen bonding. The same forces that make ice float also allow water to absorb enormous amounts of energy without changing temperature. Small molecular interactions shape the climate of an entire planet. Water doesn't just support life chemically, it stabilizes the environment life depends on. Next time we'll look at water in motion, evaporation, condensation, and how clouds form molecular collisions. Stay nerdy!